Okay, let's begin. Hello, everybody. My name is Michael Merrington. I'm the General Manager of Index. We do these weekly webinars to hopefully help everybody in this time. Thank you for attending. I will be turning off the webcam now so you can concentrate on the presentation. Okay. Index Online, webinar number 12, EXM, Encapsulation. So what are we talking about? We're talking about pieces of equipment that have some type of encapsulant that has been poured and dried inside of it, and it acts as a means to keeping hazardous atmospheres out, dissipating heat, and making the equipment safe for use in hazardous areas. By the way, these are solenoids. This is a terminal box that has now been turned into an EXM terminal box. So let's jump into it. Something pretty heavy. The order of precedence of EX documents. What do we have to follow? Well, we have to verify and validate. And you shall refer to the documents in this order. The certificates, their conditions of use, limitations, and their annexes. Then you follow the manufacturer's IOM manuals, installation, operations, and maintenance. Then you follow the standard. This is when you are in the field. A manufacturer follows the standard, applies for a testing and certification, but they also have their IOMs already completed. So any inspector that is referring to a clause reference in the standard, remember, you are referring to a minimum of the minimums. So if you refer to IP 54 as not requiring an IP washer, you may want to rethink what you are talking about. A minimum of a minimum. Have you read the certificate? Have you read the IOMs? Next, client specifications shall go above and beyond or meet these three above, but shall not invalidate. Where a conflict exists, you will refer to the highest number. Certificate overrules them all. So an example in EXM. Here we have EXM bus ducts that go all the way up to 11,000 kilovolts. Now, what do we have? Certificate number 1, manufacturer's instructions number 2, then the standard number 3. The interesting thing about this certificate is there are errors in it that I have already spotted. It said there was no conditions of use, but down in the annex, it says conditions of use. So be aware that even if the document is incorrect and goes against number 2 or 3, you still do what the certificate tells you. Always do what the highest number tells you. Now, let's jump into it. EXM, what is it? Well, it's encapsulated equipment, electrical equipment, encapsulated parts of electrical equipment, and encapsulated EX components where the rated voltage does not exceed 11,000 volts. The application of electrical equipment in hazardous atmospheres, which may contain explosive gas or combustible dust, or simultaneously, may require additional protection measures. This standard does not apply to dusts of explosives, which do not require atmospheric oxygen for combustion or pyrophoric substances. The standard does not take into account any risk due to emission of flammable gases or toxic gases from dusts, such as a dust being heated. It may produce a gas. This standard supplements and modifies the general standard 60079-0. So what does that mean? This standard 60079-18 takes precedence. But remember, what takes precedence over the standard is the certificate and the manufacturer's IOMs. Never forget that. So EXM, where can it be used? Well, it's equipment protection levels. It can be used in M's for coal mining, underground mining, GA, GB, GC, zone 0, 1, and 2. And also DA, DB, DC, dusts, zone 20, 21, and 22. Now, additional requirements of MA and MB is that components without additional protection shall be used only if they cannot be damaged, where it cannot, the encapsulation cannot be damaged mechanically or thermally in any case of fault conditions. Alternatively, where a fault or of an internal component may lead to a failure of the encapsulation due to increasing temperature, further requirements apply. Now, the maximum working voltage of actually MA for zone 0, it shall not exceed 1000 volts. The rated voltage and prospective short circuit current shall be limited by the temperature in that it does not exceed the temperature for MA, MB, MC. So the rated voltage and the prospective short circuit current is limited by temperature. Obviously, the triangle, yes. When we're talking about ignition sources, heat is a possible ignition source. So we need to limit temperature. So encapsulation, it's a type of protection whereby any parts that are capable of igniting an explosive atmosphere by either sparking or heating are fully enclosed in a compound or non-metallic enclosure with adhesion in such a way to avoid ignition of dust or gas atmospheres under operating or installation conditions and also certain fault conditions. So solid insulation means that insulation material which is extruded or molded but not poured. So solid insulation does not refer to the EXM compound. Okay? Now, they removed from the standard and moved it throughout the standard, these definitions. Unfortunately, I think that causes problems. Definitions make things clear for people. What is a void? An unintended space created as a consequence of the encapsulation process. Meaning, while something is being poured, unfortunately, the encapsulant did not get down into all the free spaces, into all the little spaces. A free space is an intentionally created space of surrounding components. So where would you see that? Well, if one of these internal components of a fluorescent light was, say, EXM, its terminals on the outside could be deemed a free space depending on how it's molded, because that is the means for connections. So when you go into free space, there's a lot of requirements. What the maximum size of free space is depending on the size of the enclosure. So we have minimum thickness of compound adjacent to a free space. We're looking at 3 millimeters or 1 millimeters. That's for group 1 and group 2. Then group 3 for dusts, there's other requirements. Okay? So voids, well, it's the same thing. Okay? So requirements of compounds. The documents shall specify the compounds used and the processing methods included ensuring to prevent the formation of voids. As a minimum, these properties of compounds of which encapsulation shall be provided. A proper selection of the compound allows for the expansion of components during operation. So there's a lot of testing and other requirements that are done at the manufacturing and design stage before they send it to an EXTL testing laboratory, and it's either approved or disapproved by the testing laboratory, which would then, once it is approved by the EXCB, certification body, or EXNB, notification body. When they are approved, that information has to be in the certificate and in the manufacturer's IOMs, the manufacturer's manuals. If you don't do as the manufacturer says, you will be working unsafe and could possibly cause the ignition of hazardous gases or dusts. So the specification for compounds, well, it says you have to have the name and the address of the compound, the exact and complete reference of the compound, percentage of fillers, any treatment required, how to obtain the correct adhesion, the dielectric strength, the temperature range, the external enclosure and temperature, the color of the compound used for testing, what color does it change to, and the thermal conductivity. There's a lot of things involved. So what are we looking at? Well, the manufacturer, the reason they have these EXM bus ducts is it allows, instead of using cables, you can use something that is earthquake proof, fire proof, and can transition zones. It can go between a zone non-hazardous area, a zone 2 and a zone 1 all the way. So it can go from switchgear or a transformer all the way over to a motor or a compressor on a train, a big GE or BH compressor. It's waterproof, it's fireproof, and it's also rated for earthquakes. So they specifically tell you how to pour these joints. Now, on the end, inside the transformer, you'll find the terminations. Now, this box is EXE. Unfortunately, somebody ran this one for 4 months with only 1 bolt on the flexible bus links, and then it blew up. So the problem is, when it blew up, this entire section had to be replaced. You're talking millions of dollars. If you don't do things correctly, somebody may say the number of bolts doesn't have to do with hazardous areas, it's an electrical requirement. The mechanical completion requires a detailed inspection. That inspector is an EX inspector. If he did not point this out, or at the time he inspected it, it was there, and then things changed, the whole point of verification and validation, pictures and documents, is to see what, how, why, and where something happened. Because someone will always try to blame the person at the bottom. It was obviously the inspector's fault. Take pictures, cover your behinds. So, requirements of compounds. Either the compound shall be tested in accordance with 811, which when you look at the bottom, that means a water absorption test. Or if the test is not performed, the certificate number for the equipment shall include the X, conditions of use, in accordance with marking of 60079-0. Now, a dielectric strength test also has to be done to a different standard, IEC 60243, at the maximum service temperature, according to 822, maximum temperature of the compound is not available from the manufacturer. Well, then another test will have to be done to 812, a dielectric strength test. Now, why do we do these water absorption tests? Why do the manufacturers have manuals? Because this happens. This has happened, and people drained away the water. They did not do proper preservation. Why? Human factors. Everything will be all right. It'll be all right. Don't worry. Now, did they do as the manufacturer said, where you're supposed to drain it, use a sandpaper of grain size 80 and roughen up the joints and then blow it with a hot air blower? Of course they did not. Do humans read the instructions? Of course they do not. This is why human factors are 99.99% of all failures. This is a case in point. This happens all the time, water ingress. Anybody that says that IP ratings or water ingress does not affect the explosion protection of EX equipment, look what's on the screen. Now, the problem is, what happened to the encapsulant? Did it absorb that water? Will this joint fail in the future? The design life of this project is 40 years. Do you think anybody will remember this problem in 40 years' time if it does fail? Probably not. Who will they blame? The installers or the manufacturers? Probably the manufacturer at that point. So the manufacturer's name is going to take a hit because nobody followed the certificate and the IOMs. Okay? Don't do like this. Now, temperatures. There's a lot of considerations. The service temperature of the compound shall not exceed the maximum value of the current operating over time, I believe. The maximum surface temperature shall be determined in accordance with under normal operation and fault conditions. So the maximum surface temperature needs to be figured out. There's a lot involved with temperatures. Now let's jump into a poll. What is the maximum rated voltage for EXM? Maximum rated voltage. Only one answer. Remember, it was at the beginning of the presentation. So 60% voted. If we could get a few more, give another 10 or 20 seconds. Okay, I'll share that. So everybody, the correct answer is the maximum voltage is 11 kV. So we have a bus duct that's 11 kV, and there's been water soaking there for a year while it's been waiting final construction. Is that going to be a problem? Certainly will. Certainly will. Now, what is the maximum operating voltage? It should say EXMA. Apologies. So for EXMA, what is the maximum operating voltage? So MA is zone zeros. Yeah. The most dangerous hazardous area type, where gas is there continuously or for long periods of time, or dusts. Give it another 10 seconds. Okay, so the correct answer is 1 kV. When you're dealing with zone zeros, where gas is there nearly continuous, you have to ensure that the temperatures are really low. The higher the voltage, the higher the temperature. So our temperature considerations, safety considerations, risks are much higher in a zone zero. So that's why the limitation of 1 kV, 1000 volts exists in a zone zero. Okay. Constructional requirements. There's a lot. The compound, where the compound forms part of the external enclosure, it shall comply with 60079-0 for non-metallic enclosures or for non-metallic parts of enclosures. If the surface of the compound is totally or partially surrounded by an enclosure and the enclosure is part of the protection, the enclosure shall meet the requirements of 60079-0. So the very first slide I showed you with the junction box with the compound inside, that's the second half of that sentence, or the second sentence there. Totally surrounded by an enclosure. Now, additional protection methods may be required. For example, additional mechanical protection. But where it is required, it may be required where there's a risk of direct impact. In such cases, the certificate number shall have the X, conditions of use, listed in the certificate. So you don't refer to this standard, you refer to the certificate and the IOMs. In addition to 7.2 and 7.9, which are coming, where adhesion is specified, the aim is to prevent ingress of hazardous atmosphere and moisture at the boundary surfaces, compound or compound parts that are not completely embedded in the compound, such as printed circuit boards or connection terminals. Where adhesion is required to maintain the protection, it shall be maintained after completion of all the prescribed tests. Now, to give an example of this would be, like we showed with the fluorescent light, some of those EXM components could have parts that are sticking out of the compound, so you can make a termination. So it's usually within another EX protection technique. Now, fault, determination of faults. Well, we need to know the most unfavorable output load, and we have to have up to two, we can have up to 2 internal faults for MA, 1 fault for MB, and no faults are taken into account for consideration for MC. So this is very much like intrinsically safe. IA, IB, IC, MA, MB, MC. 2 faults, 1 fault, no faults. But really, how many faults do we want? No faults. We should not say, oh, 1 fault's okay, don't worry about it. No, it's faults during unperceived operations of a device, not a fault due to installation from the very beginning. Install it correctly the first time. Now, examples of faults are a short circuit in any compound, the failure of a component, or faults between tracks in the printed wiring. So basically, on a circuit board, if you have continuity between different lines. Now, components that are not subject to failure for EX, MA, and MB, they'll be the following, but they're not operated at more than 2/3, 66% of their rated voltage, current, and power as specified by the manufacturer of those components. Now, the mounting conditions and the temperature ranges shall be specified, but they can be resistors, coils, paper foil capacitors, paper capacitors, ceramic capacitors, semiconductors, so circuit boards, semiconductors, semiconductive protection devices, and resistors that meet the requirement of 60079-11, intrinsically safe, IA or IB. Now, for protection levels MA and MB, they wiped out from the last standard, last edition, coils, motors, and transformers. Now they just say windings. Shall comply with 60079-7, EXE. So you can have EXMA or MB motors, transformers, coils, as long as they also comply with 60079-7 EXE, including that their wiring diameter is less than 0.25 millimeters. They shall be considered as not subject to failure if they are encapsulated according to the requirements of the standard. So if you have an EXE motor with really small winding and encapsulant was poured into it and it was tested, it could be certified to EXMA or MB. So you can use motors in zone zeros. Has it been done? Yes, it has. Go searching for it, IECEx.com. Now, just to show you an example, this is a solenoid. This one is EXMB group 2, so it's good for 2A, 2B, 2C. T5, so it gets up to 100 degrees Celsius maximum. And it's ATEX, but that is typically, so the encapsulation would be in here, and the parts would be sticking out into here for the wiring means, but this one is totally enclosed. That gland does not need to be EX because it's an integral component of this device. You connect the wiring into a different junction box. So, isolating components. The following components for segregation of different circuits shall be considered to provide isolation and are not considered to fail across the segregation. Galvanic and transformer. This is very similar to, once again, intrinsically safe, 60079-11. Or they can comply to different standards. For example, if the installation voltage conforms to the voltage times itself 2 times, so if it was 500 times 2, yeah, then plus 1,000 or minimum 1,500 volts insulation resistance. So, what about distances through the compound? As the voltage goes up, the required distance goes up. But as we know, MA for zone zeros can only go up to 1,000 volts. So you have to have a minimum of 2.5 mil compound in between everything in the device. But as you get to MB and MC, you can get up to 20 millimeters thickness requirement. Okay? So this table is here for that. Now, a visual indication of thickness requirement, wall thicknesses. It's in the standard, figure 1. The minimum thicknesses of compounds, of walls, and everything is listed. Now, what about the actual thickness of the compound itself? Well, you saw the figure. Now it starts going into other calculations and requirements. Basically, minimum 3 mil is a good measurement to have, and perhaps it could be more. So if we ask a question, see if anybody remembers, what is the meaning of a void? Remember, void and free space. I don't know if anybody's ever heard the saying, avoid the noid, avoid. Okay, so the correct answer is it's an unintended space, specifically during manufacturing or installation. We do not want voids. We do not want air gaps or bubbles that are not there as part of the design. A free space is part of the design, where maybe you have termination points. So, windings for electrical machines. Now, this is a compressor, but it's an example. Electrical machines with windings in slots and the solid slot insulation shall have, for protection MA only, a minimum thickness of 0.1 millimeters and shall be extended at least 5 millimeters beyond the end of the slot. For protection levels MA and MB, the end slot of the end winding shall be protected by a minimum thickness in accordance with 741, last slide we were in, and a dielectric strength to 824. Basically, when you're talking zone zeros, you have to be safe. Now, what did they do with this compressor? To make it EX, they poured encapsulant into the enclosure. This one is IECEx rated. They took a standard compressor, plugged the hole between the body of the compressor and the enclosure by using encapsulant. Ingenious idea. Now, when we're talking about the slots, look at all these plates here. Just give you an idea. So minimum distances for printed wiring boards. Now, this is not a circuit board. I know that, but it's an idea to show these distances. We're talking about creepage and clearance distances, segregation, and thicknesses of compound. There are requirements. Minimum for MA, 3 millimeters. So you're talking about a bigger circuit board. When you're talking about MC, you're down to 0.5 millimeters, 0.25 millimeters. So, constructional requirements, switching contacts shall be provided with an additional enclosure. So anything that switches, produces an arc or spark, shall be in a separate enclosure. Now, this additional enclosure for MA shall be in accordance with hermetically sealed so EXNC to 60079-15 before encapsulation. So if, let's say, this box was hermetically sealed, good. Now they poured the encapsulant. Maybe now it's okay for a zone 0, EXMA. The rating of the switching contacts has to be less than 60 volts and 6 amps. Additionally, the enclosure shall be made of inorganic material. I think glass reinforced plastic is an inorganic material. If the switch current exceeds the 2/3, it must be an inorganic material if it exceeds that 2/3 rating. Now, EXMB. The additional enclosure shall be made of inorganic material if the switch current exceeds that 2/3 rated current, or if the current exceeds 6 amps. MC, the additional enclosure shall be made of inorganic material if the switch to current exceeds 6 amps. So, of all these solenoids, this one's EXM, this one's EXM, this one, and this one. The top 3 on the top row right are not. But as you can see, their construction is very similar. You can have ones where there's no cabling and you have to wire it up, or it comes with it as the cabling being intrinsic to it. Ones where it is intrinsic to it, but it could go on a threaded conduit, or a cable gland that you provide goes into it. Or once again, it's integral. Now, external connections. Where compounds are used to secure permanently the connection of a cable, the cable shall be suitably protected against damage from flexing and the pull test. That would be this bottom one here and this one here. And this one here. The test shall not be performed on EX components or where the enclosure of the EXM does not serve as an external enclosure. So EXM does serve as an external enclosure on these ones because they're not multiple forms of protection. They're just EXMB, EXMA. Additional requirements for EXMA is they shall be supplied by a circuit according to EXIA or have it. So this could be an EXMA device fed from an EXIA barrier as part of the circuit. Or it shall have a connection in accordance with 60079-26, GA equipment, zone 0 equipment. Or for dusts, it shall be an EXTA. So you would actually have to have an enclosure that is rated EXTA for dust 60079-31. Now, protection of live bare parts, depending on the EPL, the live parts where they pass through the surface of the compound, it shall be protected by another means of protection. So these devices, the terminations are made inside of the EXM. The enclosure is EXM. It is not another protection technique, but it can go in a zone 0 if it's protected by a barrier, EXI. So what type of testing needs to happen? There's a lot. We already went over the water absorption, the dielectric strength test. These are tests on the compound. Now, the test on the apparatus, the equipment, we can be speaking about the test sequence of how it will be done, the maximum surface temperature, its maximum temperature, the thermal endurance test, an insulation resistance dielectric strength test, a cable pull test, a pressure, an overpressure test, test for resettable thermal protection devices. So circuit breaker, and a sealing test for built-in protective devices. Now, when we get to routine verifications and tests, this is very important for the installers, maintainers, operators, inspectors, the EPC and end users. Each piece of EXM equipment shall be subject to a visual inspection. No damage shall be evident, such as cracks in the compound, exposure of the encapsulating parts, flaking, inadmissible shrinkage, so if it shrinks too much, swells, decomposition, breaks down, failure of adhesion, or softening. This will also be done at the manufacturer. So when you do a detailed inspection on EXM, what you are looking for is, it's not flaking, it's not shrinking, it's not swelling, it's not decomposing, it's not softening, it's not darkened, it's not cracked, it's not exploded. If there was a fault, it could blacken, it could soften, it could crack. When you do a detailed inspection on EXM, primarily you're doing a visual inspection, but you can't do that visual inspection unless you open it. That compound inside that junction box, it's a visual inspection that you're doing, but you have to do a detailed inspection, meaning use of tools to open something. Dielectric strength test, I think everybody understands that very easily. So let's ask people, what is the minimum IP rating of EXM? There's multiple answers. Remember, EXM can be used for M, G, and D EPLs, underground mining, gases, vapors, and liquids, and dusts. So actually, there's 3 answers. One answer is certainly not correct. But there's certainly 3 that are. Give it another 10 seconds. Okay, so the correct answer is, well, for cable gland entry into any device, 60079-0, Annex A3 or A, minimum IP ratings for EPL MA or EPL-Ms and Gs is IP54. But you have to use a sealing means, an IP washer during testing to prove IP54. So anybody who tells you you don't need an IP washer to maintain IP54 with 6 millimeters of threaded entry, you may want to read the standard and actually follow the certificate and follow the manufacturer's IOMs. So the minimum IP ratings for dusts, you can be looking at IP5X or 6X. And for gases, so GA, GB, GC, or underground mining, MB, MA, MB, you'd be looking at IP54. IP67 is not rated for IP X6 or X5, and I still call into question any of the numbers below that. So remember, IP67 does not give you 66. Please watch our webinar number 4 and number 5 to understand IP ratings. So this one is a contentious one. Next question. Does a standard reference, so let's say 9.1 visual inspections, if it tells you something different than the certificate, does the standard overrule the certificate? So if you're an inspector and you've done one of the courses, such as EHA, Compex, IECEx, COPC, if one of them tells you, do as a handbook says or a standard says, do you follow that? For the 22% that said yes, that is incorrect. Order of precedence of EX documents. You follow the certificate, then the manufacturer's documents, then the standards. The standards are a minimum. So when you refer to IP54, you are referring to a minimum of a minimum. You are not meeting any certification, the manufacturer's requirements, or the client specifications. If you have an IP66 gland and an IP66 MA device, if you don't install an IP washer, you're actually going against the standards. You think you're meeting the standards, but you're going against the certificate, the manufacturer's IOMs, and the standards. Everybody bought an IP66 device, and you have now caused it to not be IP66. You're allowing potential water to ingress later on in its life. Please be aware. Now, does a standard reference overrule manufacturer's instructions? If there is a conflict between the manufacturer's instructions and the standard, what do you follow? Now, for the 29 or 30% who have been watching this presentation, I would suggest you watch it another 2 or 3 times. The standards tell you to follow what the certificate and the conditions of use say. They also tell you to do as the manufacturer tells you. So, please get it out of your head. The standard does not overrule an existing certificate or manufacturer's documents. Now, if there are blatant errors within the certificate that you see or in the manufacturer's documents, you shall raise a non-conformance to the IECEx or the certification body that did it, or the testing laboratory, or the notification body, or to the manufacturer themselves. I have seen manufacturers with problems in their documentation many times. I reach out onto them on LinkedIn and I tell them nicely, one-on-one, if they solve it, Wonderful. If they don't, then perhaps step it up to the IECEx. You don't want to burn bridges, but everybody makes errors, human factors, such as your answers right now. People don't like being told they're wrong, and they will always fight it even when they're shown they're wrong, they will fight it. But you know, the wonderful thing is on the next slide, which is directly from the standard, what does it tell us for marking? This would work. 1 second. Apologies, give me a Chrome. So what does it say within the standard? Well, it says everything must be marked with the rated voltage, current, prospective short circuit current, whether it be 500 or 3500. Oh, and also down at the bottom, alternatively, the marking shall indicate in C, D, and E above can be included in the instructions and equipment. So the instructions, the manufacturer's instructions. And the equipment shall be marked with the X to indicate the specific conditions of use in accordance with the specific conditions of use with the requirements of this standard. So the standard is telling you, go to the certificate. And it's telling you use the manufacturer's instructions. The standard is telling you to not use the standard. It's telling you follow the standard and go to the other documents first. So really, you shouldn't need access to the standard at all times. You shall follow, well, let's look in a logical method. This bus duct, you go to the IECEx website and you get the certificate. Now, unfortunately, the certificate says there's no conditions of use. But when you go into the annex, well, it says full conditions of the certification. Those are conditions of use. But sometimes English has translated the meaning differently between different certification bodies. Routine tests, a dielectric strength test shall be done, a visual exam shall be done. So do you do what the standard tells you, or do you do what the certificate tells you? You do what the certificate tells you, which should be identical to the manufacturer's IOMs. If you are referring to the standard for all clause references, you are not following the order of precedence with EX documentation. If you don't have the certificate on you, you are not doing the inspection correctly. It is invalid. Your inspection is completely and utterly invalid without knowing the conditions of use. So, human factors. Does everybody know this requirement? 30% are already disagreeing, so it's an industry-wide issue. So, how does the equipment marking have to be identified? Multiple choice. First person who answered had all the right answers, whoever that was. %, give it another 5 seconds. %65 voted. Now, the correct answer is all of them. It shall be on the equipment. But if it can't be on the equipment will have a certificate number with an X with the conditions of use and listing the voltage and current ratings. So both those answers are correct. Also, yeah, it has to be on the manufacturer's data sheets, installation, operation, and maintenance manuals. A data sheet is a manual. So if we go back, it's listed, their voltage is 1,000 or 3,000 volts on that. Current is 3,420. They've listed it on there. They've also listed it on the certificate. And I can tell you it's also in their IOMs. So if you go back here, it shall be marked on the equipment, alternatively on the certificate. Oh, and included in the instructions. Where do you find instructions? Well, the manufacturer's instructions. Certificate, IOMs, then the standard. Where's everything marked? You compare the EX data plate to the data sheet and to the certificate. If you are doing inspections without a data sheet and the certificate and the IOMs, comparing them out in the field, visually proving it, you are doing inspections incorrectly. That's going to hurt a lot of feelings. People are going to disagree, but it's okay to disagree. It's okay to be wrong. Human factors. Now, Annex A, basic requirements for compounds for EXM. This is for the manufacturers of how to select the correct type of compound. Temperature range of the compound known? No. Well, select another material or redesign. Yes. Is the compound inside of another EX protection technique? Yes. Everything's nice and easy. If no, then they have to do other tests such as TI, I'm not sure which that one is, electrostatic test, mechanical test, group 1 tests, or just put in another EX protection technique and nice and easy. Does it need to be protected against light? Yes or no? Yes. Has to be resistant to light to tests identified in -0? No. Are there bare conductors? Yes. Protected by another EX protection technique. So I showed you those bus ducts. The end termination is bare. So they had to be inside of an EXE enclosure for that transformer terminations. If no, provide test sampling. Then it goes to the EXTL for testing. If it passes, it goes to the EXCB and they write the certificate. So let's open it up to questions. If you have any questions, please ask, because the information is very easy to find. You go to the IECEx website, you get the certificate, you download the manufacturer's IOMs, get that data sheet, and refer to the standard if you need to. But there's all the documents needed on the screen and previous slides back. So if anybody has any questions, please feel free. So EXM can be used for motors, transformers, solenoids, bus duct. It can be used for many things. A compressor. There's the example of a compressor. So motors for EXMA or MB pumps. I would suggest you consult with us. We are a group of 10 companies. If you contact us at info@ind-ex.ae, we can assist. Now, MA or MB pumps are rare. EXM, most people are used to the solenoid type, such as this. Most are not used to the bus ducts or motors. It's just because people did not have a very good understanding. The manufacturers did not have a very good understanding of how they could use EXM to their advantage. Places such as Canada does not allow EXMA in a zone 0. They have their own national requirements. Pros and cons of using EXM over EXQ. Well, EXQ, I'm forgetting the maximum voltage, but EXM can be used in a zone 0. EXM, the encapsulant isn't going to leak out. EXQ, if it cracks open, the sand will leak out. So when you do a detailed inspection of both of them, it's more that you're doing a visual inspection once you get into the device. You have to look internally to do a detailed inspection on something that you have to do, you can only really do a visual inspection on. EXQ and M, you're primarily just doing a visual inspection at the detailed inspection stage. Maximum rated voltage for EXMA is 1,000 volts. B and C is 15,000. No, 11,000. What did I say in the beginning? 15,000, 11,000. Maximum 11,000. So Q, I can't remember the maximum voltage, but Q is not used very often. So if we look at a fluorescent light, many times the internals are EXQ or M. M is easier. It's just pouring a compound that then hardens. Find it very hard to find any IECEx pumps for gas sampling applications with approximately 5 liters per volume flow. Preju, please send us an email. Respond to our emails. We can assist. If the EPL of a solenoid says GB but is MA, can it be installed in a zone 0? No. So what that is sometimes a manufacturer will manufacture an assembly line and they'll have EXM, it'll have an EXM solenoid, but they want to sell them also to people for zone 1 or 2. Now the thing is they'll use the exact same piece of equipment, but maybe they'll change some of the internal components. Maybe it'll produce more heat. So if it produces more heat, it's still MA, but once it's assessed, okay, it can only go into a zone 1. So therefore, then they identify it as GB. So what they're doing is they're producing the same piece of equipment, but it would have different power levels, different temperatures. So if you have an MA device that is rated GB, EPL GB, it can only be installed in a zone 1 or 2. Always follow what the EPL says, the equipment protection level. ABC, zone 0, 1, 2. DA, DB, DC, 20, 21, 22. EXM product, is it possible to open and do maintenance? The compound is hardened. You do not do maintenance on the compound. You can do maintenance on the enclosure, on the terminations, but no, you do not mess around with the compound. It is hardened, it is permanent. Do not touch it. Hi, insulation layer on a circuit board. Is it a solid insulation or not? Yes, EXM is a hardened barrier. So if we go back, it's a hardened compound. It's not to soften, it's not to be cracked, it's not to be opened, it's not to be modified. It is what it is. When it's done, it's done. You cannot do anything else with it. EXQ mostly used for ballasts and chokes. Yes, but also EXM can also be used for ballasts, transformers, motors. It's just not realized very well. So in this instance, this is an example of it used for a condenser. Now the ones where you have the bus duct, the reason it's used is it's much better than cables. It can withstand fires for longer. You can put more current through in a small space because it has thicker, stronger insulation, higher dielectric strength than a cable does. So the weight would be less than cables, the size is less than cables. Over the long run, the initial cost may be the same or more, but the benefits are immense. Now, if we don't have any more questions in the next 30 seconds, we'll thank you for attending. Now, to give you an idea, that mixing of the compound, while installers do that in the field for this such installation, the manufacturer does it at their location before they sell you equipment. Bus bars don't provide the same flexibility of cables. You have to be exact with bus bars. With flexibility, we mean flexibility in where it can be used. We don't mean the actual flexibility of a cable. Flexibility as in you don't have to worry about breaks in a cable, insulation resistance, how many cables you need, weight considerations. The weight of that bus duct, the amount of amps it is putting through, would require significantly more cables over a bigger space and significantly more weight. This is more condensed, compact, and efficient. It's a more flexible option for such uses as from switchgear to transformers, transformers to motors, permanently hardwired connections. We're talking big current or big voltage or both. Obviously, not one small little motor. Okay, want to thank everybody for attending. We hope you enjoyed the presentation. Ran an hour and 4 minutes, 4 minutes a little longer, but thank you very much for attending. We really do appreciate your time, and good morning, good afternoon, and good evening. Thank you very much. My name is Michael Merrington, and we really do appreciate your time. If you have any questions, please contact us at info@ind-ex.ae. You can contact us on WhatsApp at any time. If you are looking for parts, components, you need product certification, personnel certification, training, inspections, consultation, please contact us. We are glad to help you. Thank you very much.